There we go. Sorry. So it's important to mirror your nutrient contents in the soil. Make sure you see how much you've taken out of the system, and then determine how much to replace back into the system. Does that make sense? Okay. So by harvesting, you're taking nutrients out of the system. They need to be replaced. They need to be put back somehow. Yeah? Okay, so looking at soil health, we have looked at the importance of organic matter in the soil. So there was a few lectures back. Nutrition is another part of soil health, and it encompasses organic matter, so that's just part of it. The term soil health therefore applies to physical properties, chemical properties, and biological properties of the soil. All of these things work together to provide you with a healthy soil. So biological would relate to like your organic matter. Physical relates to your texture and your structure, those kinds of things. Chemical would be more like your pHs, cation exchange capacities, those kinds of things. And all of these characteristics come together and fall under the umbrella of soil health. So they're all contributing to you having a healthy soil for plant growth. Okay. So healthy soils, if we look at defining them, they are able to sustain life of organisms in the soil. They would also be able to suppress any pathogens, so a healthy system is able to prevent any pathogens from growing and keep those kind of small amounts, so there's not so much disease pressure. A healthy soil also is able to provide enough water and nutrients to the vines, and there's also some sort of a system available to decompose organic matter, so releasing nutrients from organic matter back into the soil. The characteristics of a soil will influence the storage and availability of water and nutrients in the soil. So now we're coming back to water, and we know that the amount of water that can be absorbed or stored in the soil is related to its physical characteristics as well. Nutrients are also dissolved in the water, and this will therefore influence their movement through the soil. So nutrients have to be dissolved in water, and then they will then be absorbed by the plant. So again, water movement through the soil is very important, because that's what the nutrients are moving through, moving with. Okay, so without water, the nutrients can't really get into the plant. So these will include stuff like depth and fertility, texture and structure, soil chemistry, soil biology, and organic matter. So this is just a quick slide kind of trying to define what soil health is and why it's important. Any questions so far? Okay, so the next thing I want to do is do a little class discussion. So these factors of soil health are all very important, and we have touched on all of them during the course and also in soil science a bit. And here we're going to try and bring them all together under the term of soil nutrition. Okay, so to help you to really understand and bring all your knowledge together, we're going to do a little think, pair, share. So I'm just going to pair you guys up. So I'll just do Chris and Robbie and Bo and Angel there at the back. So just team up with a buddy and discuss how each of these factors can contribute to vine nutrition. So depth and fertility, texture and structure, chemistry, biology and organic matter. And then just make some notes and ask any questions that you have at this stage. So this is really using all of the knowledge that we have built up until this point to try and see how it influences soil nutrition. Okay, and you're going to have, I'm going to give you about 10 to 15 minutes to do this activity. Okay, so it doesn't have to be really intense notes. It's not answering a test. Just think about it. How would stuff like texture and structure influence plant nutrition? So they think about, porosity, water movement, aeration. Are the organisms able to get oxygen to decompose? That's all related to structure and texture. So just things like that you do actually know them. You might not just realize that you know them.
So with depth, is that referring to like the
rooting depth?
Rooting depth or like soil sort of depth?
So it's soil depth, which is related to rooting depth. So how deep can your roots go to access water and nutrients? How deep would you expect nutrients to be available?
Yeah.
So fine root hairs are normally in the top layer of the soil because that's where all the nutrients are. Your organic matter is normally in the top ones, but with vines, you kind of want to encourage them to explore a bit. So having a really good rooting depth for vineyard is quite beneficial as well.
Yeah.
Yeah.
Yeah, so like what with depth, obviously like having soil that's not too compacted, so that like roots can be able to get through the soil more. But just
topsoil with subsoil, slightly fertile more.
yeah, definitely. So like having my soil like this, like that top layer there being more fertile than this, so more fertile, and then like it maybe isn't as important as it's because like if the vine comes out, most of all those like fine small root hairs are going to be all on this part, and then down here there might be only a few. So that top part would be the more important. Yeah.
This maybe divide penetration to more deeper.
Yeah, but then yeah, again, like if the soil is too fertile, then your vine roots might stop out here, and then they will only stay in this area. So perhaps sometimes having a like subsoil that isn't as fertile as say your organic layer would encourage your vines to grow deeper and spread further in search of more water and nutrition, which could be beneficial for instances like if you had like a drought. If you have a soil like this where it's all nutrition up here, and then a drought event occurs, then your vine is only relying on this top layer. Whereas if you have a soil that isn't as fertile up here, that way the vine can search further or have to search further for more nutrients, and then if a drought event occurs, then this has a lot more of yeah. Yeah, so it's interesting. Alright, next one. So I guess like we know about texture and structure, like it's all like having clay, sand, and all that sort of stuff. Like all of that will be contributors to how a vine's going to be able to collect nutrition, right? So like cation exchange capacity and all that sort of stuff, and same with like what compaction for your texture.
And also the infiltration rate will
Biology and organic matter.
influence.
So how does organic matter contribute to vine or to nutrients in the soil?
Yeah. But yeah, so it's saying how texture contributes to vine nutrition.
It's part of it, so nitrogen is one
Obviously,
thing,
we know that's
but organic
how
matter includes
nutrients
lots of
being
nutrients.
able to hold on to those nutrients for when the plant needs it and not just being leached out.
So if you think about decomposition,
Yeah.
you have
Well,
organic
yeah,
matter
pretty
on
good
your,
at
in your
understanding
farm,
texture and structure
and it decomposes, so you have those microorganisms decomposing it, and they're releasing nutrients into the soil. So remember mineralization and mobilization. Okay, so it's releasing nutrients bound up in organic forms, converting them to inorganic. Yeah, yeah. So nitrogen is in the cycle, but a lot of other things are in the cycle too. Actually, everything is sort of in the cycle.
Soil chemistry.
Yeah.
Soil chemistry be also the cat.
Yeah.
capacity.
So, depth again, you thinking about depth
The
of
ability
soil,
for
so
the
how
soil
deep
to
would get
hold
such
on to
a
those
lot of
nutrients.
the water table or something like that. So that's basically your potential rooting depth. Okay, so how
Some
you
people
can
are
actually
maybe not
penetrate
the
the
soil
soil to
condition,
generate.
but more of the biology.
That depends on the type of thing you're planting.
whole,
The roots of grass is going to be shorter than roots of vine. Roots of vine, you want them to
So
have quite a lot of
microbes
rooting depth so that it can spread its roots far over the water and nutrients.
organic matter into biodegradable
So having a good rooting depth on a vineyard is going to contribute to its health.
good soil biology.
Yeah. In chemistry, remember pH? Yeah. So which type of soil has got higher CEC?
Clay soil.
Clay soil. And high CEC soil or a low CEC soil is going to be better at buffering pH. High. So clay soils are better at buffering when pH changes. Okay. How are you guys doing?
Yeah, I think we've got a fairly good understanding of things. So like here we're talking about the whole depth of fertility.
Yeah.
So like having a soil that's more fertile in the topsoil and subsoil is going to be like good, but also if you had a sort of high stress point like in a drought and a vine with all of its nutrition kind of held up here is just not going to be able to survive for as long compared to having this a not as fertile soil perhaps where vines are able to explore a bit more.
Exactly. Yeah, that's a very good point. Exactly.
So it's all good having a fertile soil and doing that, but if you did have a stressful period, then it's not really going to do so well if it all dries up and then you find yourself stuck in that zone.
Yeah, and you find that more people are might start reducing irrigation on purpose because we're going into London conservation. Everyone's becoming concerned around that, and people are deficit irrigating to try and get better quality. So you might find that that's going to potentially dry out regardless of the weather because you're irrigating in certain ways and purposes. And then you want, like you said, you want your vine to be nice and established so that it doesn't die to freak out too much when you do those kinds of things. So yeah, that's a very good point.
Yeah, and then I guess we're talking about texture and structure, just like that. That whole sort of, well, I guess we're sort of combining all of it together, talking about the CSC and these different textures.
Yeah.
And then, yeah, of course, the whole structure, like having a compacted soil over a bit more of a loose soil will allow the vine to be able to find the nutrients a lot easier and explore.
Exactly. And remember this, the CEC and the pH also relate to nutrient availability.
Yeah.
So having a high CEC soil has got more
Yeah.
things attached to it. Higher buffering capacity, which is great because having changes in your pH also affects whether nutrients are available or not.
I guess that's rather than like saying with soil pH, only like some nutrients are available between a certain range. So if you've got too high of a pH, or you won't be able to get some of these things on the middle. So
You do know all of this stuff.
yeah.
Bringing it together. Excellent. Okay, great. So,
Yeah, that was just like one there, and you can see it was like that's that one. Those ones all available at different. Yeah.
so this is a good demonstration of bringing all of your knowledge together now to answer one or think about one sort of concept, which is soil nutrition. So at the back there, Angel and Bo, what did you think was the importance of texture and structure?
Good structures can hold more nutrition in them.
Yeah. And yeah, what else?
So they can supply, plants can take nutrition easily from the soil.
Okay. Bo, did you have anything to add there?
Structure.
Drainage, good drainage.
Yes.
Good.
Good, yeah, so you have good drainage, better porosity of your soils, so more air spaces. Exactly. The texture as well relates to your cation exchange capacity, which relates to your nutrient content, like Angel said. So having a soil that's more clayey is going to have a higher cation exchange capacity, which means there's going to be more nutrients potentially in that soil. Yeah. Okay. Cool. So that's just a nice little exercise, an example. This is all kinds of things that you're going to keep in mind. So it's good to come to grips with this type of thing, because when you're answering questions around soil management, you're going to be thinking about these kinds of things quite a lot. So you always have to consider texture, structure, organic matter, water relations, what else is there? Chemistry, those kinds of things. This is where it's important to have that knowledge in your mind. And you guys obviously know it because you just told me all the answers, and so you know it, it's in your head. It's just about bringing that to the fore and making decisions using that knowledge. Okay. All right, so it's just, here's the looking back at pH a little bit, so just reminding you about pH. And this is relating specifically to vineyard now. So this is very similar to other figures that you're going to find, but I decided I wanted to show you one that relates to vineyard specifically, because pH changes affect different soil type or different plants in different ways. So some plants like high pHs, some plants like low pHs, etc. So this one is nicely placed with these two red lines where a vine likes to be, which pH a vine likes to be in. And this I got from a really good source at this link. I've actually based most of this lecture on that link. So I would definitely recommend that you guys go and open this, look at it. I would probably even print it out if you could. I've made one for myself. I've made it into a little book. It's called Managing Grapevine Nutrition and Vineyard Soil Health. So have a look at that and pass it back. It's really nice. It's got lots of cool pictures, lots of information in there, lots of like little guidelines and stuff. So I thought this was really great. So have a look at that. I want to see if I can get Sue to approve me printing one for each of you.
Yeah.
It's just that it's a 32-page book and it's going to cost a lot. So yeah, so this is really nice. So go have a look at it. So it's managing grapevine nutrition and vineyard soil health. That's like really exactly what we're doing. And it's just got really nice information in it. So let's see. So there's a picture that's on the board there. There's the pHs. They're speaking about the different soils. They're speaking about the different analyses you can do. It's got little tables with guidelines in there, which is really nice. So there's like typical amounts of major nutrients exported from the vineyard, so you can see sort of more or less what's happening. It talks about all the different nutrients the vine needs. So it's really, really, really nice. Yeah, it goes into fertilizers, different ways to fertilize vines. So I feel like this is a really nice resource just to have and keep with you. Like a tiny little miniature summarized textbook. Okay. So we know that pH changes nutrient availability. There's a reason for this. Does anyone know why pH changes nutrient availability? So there's only 4 of you, so you guys can discuss it amongst yourselves if you like. There's sort of one main reason.
Is it the whole ability to swap out hydrogen ions?
Yeah, it's related to that. Let me know when you give up. It's related to that soil chemistry, yeah. So think about when you're introducing hydrogen ions into a system or taking them out, you're going to start changing things. So if you have
more negative and positive.
Yeah, so it's going to start wanting to come into equilibrium. So this is thinking back to chemistry. So if you're bringing in hydrogen ions, taking away hydrogen ions, it's going to try and come into equilibrium. So it's going to take or add ions, cations, whatever, from the nutrients that are there, from the elements that are there. So essentially it's going to be changing the structure of certain things. So So if we think back, remember when we did iron chlorosis, we did that as an example. It's at very alkaline soils, so very low pHs. The iron changes into a form which is not soluble, okay, because it's being, I think it's oxidized. I can't remember exactly what it is, but you either have oxidation or reduction. In this case, the iron Fe3+, I think, which is the one which is available to plants, was changed into a form which is not soluble in water. Because it's not soluble in water, it can't get dissolved in the water, and then it can't move into the plant. So plants take up nutrients, or nutrients are more available in certain forms. And when you start changing their pH, bringing in hydrogen ions, taking away hydrogen ions or hydroxyl ions, or whatever the case may be, you find that those elements or those ions change their function or their form. So they become less negative or more positive or those kinds of things. And because they change their form, they become potentially less available to plants because they're just not soluble in water, or they stick more strongly to the soil or something like that. Yeah? So the pH, changing the pH leads to potentially leads to changing the form of those nutrients. Okay? Sometimes those forms are not available to plants. So this is why the vineyard likes to be in this range, because in that range, a lot of the nutrients are available. So you'll see most of the lines there are fat. Okay? Over there they start getting really skinny, and on that side as well. So in this range, you find that the majority of nutrients are in an available form for plants to take up. Okay. Does that make sense? Angel, make sense? Cool. Okay. So this is why it's really important to check your vineyard soil, so you can apply any ameliorations if necessary. That's a new word, ameliorations. Anyone know what that means? It's just a big fancy word for saying changes, basically. So additions or removals. So changes to the soil. So if I look up let's see what Google says the definition is. Amelioration. You might find this word quite a lot when you start reading sort of soil sort of documents and things. A lot of them are going to say we ameliorated the soil, or there was soil amelioration done, so it's good to know what this term means. Basically, according to Google, it just means the act of making something better or improving something. So by adding something or taking something away to make it better. So in this case, the something is soil. Okay, so if you ameliorate the soil, you're adding something, taking away something, changing something to make the soil better. Okay, so when I say that you need to check your pH regularly, or it's important to check your soil pH because you need to apply ameliorations, it just means you need to make any changes. Okay, to improve that soil, to make it better. Yeah? So the problem of acidic soils is generally more common, so you'll find that of the two, you're going to struggle more with trying to correct acidic soils. And this is relatively easily remedied with lime. So we've all, lime, I think it's calcium carbonate, basically like chalk. And you just apply that in the soil and that corrects your pH. Okay, it depends on how much you apply, so you need to make sure that you work out the pH properly and figure out how much to apply. Normally, some guy will come onto your farm or a girl and take measurements in the soil, and they'll make a recommendation. There's also sort of online new fancy technology which does all of these calculations and stuff for you with your soil data. Okay, so you will know how much to apply. When to apply it is another issue. So normally it's better to apply lime before you plant your vineyard. So it's good when you're establishing a vineyard, and you might have heard this in vine establishment if you do that, that it's better to do your pH checks then and change the soil before you plant, because it's just easier to do it then. So doing a lime application in an unplanted plot, it means you can rip that soil and work it into the soil nicely so that it fixes that pH to a better degree. You can do it when your vineyard is already established by doing like a sort of top layer of it, so just putting it down in the interrows. But it's just harder to like really work that into the soil when your vine's already established. You don't want to be doing like hectic ripping down the rows. You might end up root pruning or something, so it just becomes a bit trickier to do. Okay. Alkaline soils are less common. It's not such a common problem to deal with, but you can remedy that by using acidifying fertilizers. So just applying fertilizer that acidifies the soil. The other way is using organic matter. During decomposition of organic matter, it's going to give off like different types of acids. Humic acid and fulvic acid is the other one. And those acids are going to then decrease the pH of your soil. This will obviously take place over time, okay? And you might, it's difficult to control that as well. So you might find that you go too far and then you need to fix it back again. So you can, organic matter will acidify your soil to a degree in any case. So you incorporating that could fix a high pH soil, but it's just be aware that it's difficult to control and it might take a bit of time for it to actually have an effect. Okay. Moving on to CEC. So this is also linked to chemistry. So the first thing I want to ask you is which type of soil will have a higher cation exchange capacity, and why would you say so? So this is back to soil science.
Clay.
Yeah, clay.
Yeah, and because clay have more cation exchange sites.
Yes, exactly. And why does it have more exchange sites?
In the same volume of different soil compared with sand, let's say, yeah, clay have more surface area.
Yes, exactly. So it's clay. Okay. More exchange sites. And that's because of higher surface area. You remember this from soil science? Good. Excellent. So I've written there, discuss in your groups why you think cation exchange capacity plays such an important role in plant nutrition. Think about nutrient availability and buffer capacity. Think about the pH, changing the form of nutrients to make them less available. Again, you guys can discuss in your group of 4 if you want, or 2 is fine. So this is just a quick discussion, like 5 minutes. Just think about why CEC is so important.
Obviously, like, yeah, like I think you like get the fertilizer. Being able to exchange those ions for the fertilizer ions they flow down the road. If your soil can hold on to those ions for wind and climate, then the ability to sort of increase or decrease, change the sort of pH. What do you guys think? What do you guys think?
So it can hold essential nutrients in them. So because of more exchange sites,
So if you've got like a soil that has like a low CEC, and if you go and fertilize your soil, they won't be able to hold on to those soils as buffer capacity. The buffer capacity is the whole like being able to adjust the soil pH, right?
Yeah, so
Is that sort of-
it's got to do with resisting any changes in soil pH.
Yeah.
So that means if you have a higher buffer capacity, it means the pH is more stable in your soil, which means that you don't get that changing in the forms of your available nutrients. So those nutrients will be, they'll kind of stay more stable in their available forms if the pH doesn't change so easily.
So if you like threw down like nitrogen fertilizer and your soil doesn't have or has a pretty cramped buffer capacity, then it could just like change that into a non-available form of.
Yeah, so potentially you would be able to, or it would change, your nutrients would become unavailable to those plants because they're changing their form into a non-soluble form or something like that can't dissolve in the water. Or nitrogen as well it can either be an ammonium ion, so NH4+, which means it can stick to soil, or it can be an NO3 or NO2-, which means it can't stick to the soil. So those forms are more prone to leaching. Yeah. So you get different forms of these nutrients. Okay. So it's not just that one form, and it can change. And some are more available, some are less available. Some are more soluble, some are less soluble. Some stick to soil really easily, some don't. And depending on what form is in your soil, it will either be able to be taken up by the plant really easily or not. Okay. And the CEC, that's important because higher CEC, like we said, has got more exchange sites, which means it's able to hold on to more nutrient ions. Yeah? So it's more little negative sites that can hold on to those nutrient ions. Okay, so which stores them sort of in the soil so that plants can exchange ions for them if they need them. The thing with sticking those nutrients to soil particles means that they need to be exchanged before they let them go. Okay, so sometimes if you have nothing to exchange, for example, they will just kind of stick onto those soil particles. Other things like the NO3- and NO2- are readily available to plants, so they're just hanging around in the soil solution because they can't stick to the soil surface. So the plant doesn't need to exchange anything for them. They can just move into the plant easily, but they can also be leached out very easily. So yeah, so that's the downside of it. So that's thinking about like timing of irrigation versus nitrogen application. We need to think about, you can't irrigate right after putting in nitrogen because half of it might be washed away. Yeah. Great. There. So remember, clay soils have a higher surface area and therefore a higher cation exchange capacity. Higher cation exchange capacity have a higher buffer capacity and resist changes in the soil chemistry. Soils with a lower buffer capacity won't resist the change as well, and some nutrients may become unavailable. Okay, so bringing all of that prior knowledge into use now. So I've just put this up again to remind you of the plant available forms. I know I show you this a lot, but it's just important to remember that plant available forms are going to be in an ionic form. Okay, so ammonia is going to be a plus or a minus, so there's the minuses. Calcium is going to be in a plus form. Mg is going to be 2+ form. Okay, so they're going to be anionic. Okay, so they have to be in that ionic. They have to be in an ionic form to be taken up by the plant. All right. Okay, and this is just because they need to be dissolved in the water to move into a plant. Okay. Do you guys have any questions at this point? I'm going so fast through this. You guys are so on the ball today. Okay. Now, this is going to be a challenge. Okay, nice challenge for you guys. We're going to think about the different soil types that we have, and I think we're just going to look at, well, let's do sand, silt, and clay. Okay, so silt, remember, is in the middle, half and half. And because there's 4 of you, we could potentially do 1 poster, or we could do 2. I don't know what you prefer. And I just want you to do a poster on the different soil types, and then think about their different characteristics. So we know about all these different characteristics of the soil types. and how they contribute to nutrient availability. So again, we're thinking about texture, structure, chemistry, all of those kinds of things, and we know that different soils have different characteristics. Okay, and this is again just a different way of you bringing all of your knowledge together, putting it down on paper in a summarized form so that it solidifies it in your mind. I feel like this is something that you might find a lot when you go into industry, is working with different soil types and knowing how they respond or react in terms of nutrient availability. So you know now how to test whether you have a sandy or a clay soil. This is going to teach you how to know what that means in terms of how do we give nutrients to the soil, how do we manage nutrients in the soil. Okay, great. Is that any questions? Okay. So do you want to read just all four together or two?
Or we go together, or we can make a poster on the whiteboard rather than
On where?
on the whiteboard.
Write it up on the web.
Oh yeah, you can do that too. Yeah, for sure.
Save some paper.
Yeah. Okay. Okay. Just be aware that you're going to be recorded if you come onto the whiteboard. Yeah.
No problem.
Okay. So where are my colours? I've only got 4 colours for you. Okay. One for each of you.
Under sand here. Seal and clay. Sand.
If you want quick notes, there are some in that book. And this one. Yeah. So,
So what was like sand and be lower nutrient holding capacity?
let's put that on. There you go. Yeah, so some extra notes.
No, sorry.
So yeah, silt and loam is more or less the same thing. Yeah.
Drainage, rapid drainage.
Yep.
Which would not mean increased leaching.
Yep, so you have potential for increased leaching, but also you need water for nutrients to actually move into the plant. So by having better water movement, you also have or easier water movement. So if we think about hydraulic conductivity, the easier water moves through the soil, the easier it is for a plant to take it up.
Easier water movement was
Hydraulic conductivity.
Low level of organic matter.
That's in sand. Yes.
Low organic matter level. Clay, I think high.
Yeah.
High organic matter level.
And just organic matter.
C is low.
Low CC sand.
yeah, without silt, was silt just somewhere in the middle?
Yes, it's got a very tiny paragraph here as well, so it's in the middle.
Yeah.
Because only K, the drainage for a slow, is not good for the irrigation. Yeah, if you have a heavy rain, the case soil maybe have waterlogging, so have the soil have retained.
Exactly. So that's a
Yeah.
very good point. Having waterlogging is not good for your plants.
Yeah.
If we think about nitrogen, do you guys remember what happens to nitrogen when there's waterlogging? Do you remember the name of that process?
So kind of also like denitrification.
Yeah,
as well.
that's exactly what it is.
Because
Denitrification.
yeah, what changes like, well the hydrogen ions on like ammonia and stuff get bound or something, or they get lost and it just converts it to like E2.
Yeah. So
Get back to the atmosphere.
Yeah,
Yeah.
exactly. So your plant available nitrogen is converted back to that N2 form during denitrification, and that happens. You don't have to know this because it's very technical, but that happens because in waterlogged soils you don't have oxygen, so the respiration becomes anaerobic, and then they start using NO3 minus as electron acceptors in respiration, and that converts it back to the nitrogen gets released and back to NO2. But denitrification is the word, yeah. In clay as well, you won't have as much leaching potential because it doesn't drain as fast. So again, these things are sort of twofold. You can't say, oh, clay is better than sand because each of them have their characteristics. Each of them have advantages and disadvantages. What about the pH?
So what sand also has lower buffer capacity.
We mean the natural pH or
7. I don't know.
well, we just less change.
Okay.
So higher buffer capacity, yeah, less change. Yeah. So you say crust formation? So that's a problem with clays, again related to drainage. So
If like a clay soil dries out, then it can start to crack and stuff.
yeah,
which
so you find that the water sort of doesn't drain through fast enough. It sits there, and then when it can lead to that cracking of the soil surface. Yeah.
So
Crusting.
like if you do end up having like a water event after like a dried out kind of clay soil, then it just won't just like either pass straight through the soil or just like run straight off the
Yeah,
top.
exactly.
Crusting.
Yeah, so it
Crusting.
forms
Crust.
So we think about a crust, it's just like a layer, sort of a hardish layer that forms on the soil surface. And like Robbie said, if you have a rain event or irrigation again, you'll find that the water will just run off that crust mostly because it's formed this sort of hard layer on the top. And you won't be able to get good penetration down anymore. So you'd have to sort of break up that crust before you can get penetration into the soil.
Yes, is that kind of how you end up with like flash floods?
Yeah.
Just like dried out events or whatever, and then if you get a massive rain event, all of that water just rushes straight through
Yeah.
rather than penetrating through the soil sometimes.
Have you all seen that in a riverbed when a soil starts making that layer? See the riverbed sort of dries up and it makes those cracks.
Cracking.
Yeah. So that's probably a very high clay soil. So it's made that sort of crust, and as it dries out, this clay is probably shrinking, and then it makes those cracks. But generally, they won't be very easily infiltrated, those crusts. Good. I think you guys have got some good points here. Is there anything else in our notes?
So this is kind of
Replication difficulty.
somewhere in the middle.
Yes, so that's related to the cation exchange capacity, so the nutrients are falling maybe a little bit less. You don't have such a high CEC. Yeah, leaching.
Higher organic matter. Good mineralization.
Yeah. Mineralization, yes. So, more organic matter, we have higher potential for mineralization and more nutrients then. Yeah. Cool. So if I asked you, I have a grapevine, where would you, on a scale from sand to 100% clay, do you think you would fit grapevine in on that scale?
Depends on what variety and what
Oh, I love that. I love that.
what quality of grapes
Perfect.
you want.
So if you had a scale, it'd be like
Perfect. Yeah. It does all depend. It does all depend.
You want to
But-
grow some our grapes, we need like sliding tension clay soil.
Yes.
So if you're kind of like going for quality, you'd want to be somewhere like here
Yeah.
for quality.
Yeah. Do you guys agree? Yes.
Kind of not too sandy, because then
Yeah.
you could just
Some stress.
Oh, you guys are crushing it today. Nice. Okay, so this all makes sense to you. Okay. Does it help you to bring all of your soil stuff into perspective now a little bit? Yeah, it makes you know like, oh, now I know why I had to study all of that for so long. Good. Cool. Any questions from anyone? Take a photo of this so I can put it up on the site. Okay, so moving on to how we measure the nutrients in the soil. Oh, no, let's turn the lights off a little bit. There we go. Okay, so there's a couple of ways that you can determine the nutrient status of your plants. One of the ways is just by looking at them. Okay, so just observation of your plants. Vines, as we know, we did it a bit in soil science. You have deficiency symptoms and you have toxicity symptoms. So having too little of a nutrient is bad, but having too much of a nutrient is also bad. There's a in-between sort of range where you want to be with nutrients, okay? And it, again, as Chris so well puts it so well, it depends.
Yeah.
Okay, it really depends on the cultivar you have, the rootstock you have, the soil you have, whether the amount of nutrient that you're giving that vine is going to be good or not. So if you have super high levels of nitrogen, we know that that's not a good thing for a plant because you're going to just have vigorous vegetative growth. Yeah, for example. Okay. The other way that we can test for nutrient status is by doing soil tests. Normally you would send these tests away to a lab, so you guys probably won't be doing these tests yourself at any point, but it's good to know you can do these different types of tests. And the information they feed back to you is normally in a table or form that's very easy to understand. So all you need to know or need to be able to find is the ranges that is appropriate for your farm, and you'll probably find that you'll get this from historical data from that farm. The previous viticulturist will know, or the lab that you've been sending samples to for like years and years will be able to tell you. So it's relatively easy to get this information because the labs will send it to you, but you need to send them the samples. Okay, so it's important to take enough samples so you get a nice, good representation of your block. And the other thing that you need to note with soil tests is that they're not always super reliable, especially when you're trying to see how much or the nutrient status of your plant. So as we know, not all nutrients can move into the plant or will move into the plant. So that's to say, you know, the nutrient status of my soil doesn't necessarily mean it's the same as the nutrient status of my plant. So if I have 10 milligrams of nitrogen in the soil, for example, doesn't mean I have 10 in the plant. Yeah, because we know that it moves into the plant based on 100 different characteristics. Okay, so you can do soil tests. It's a really good idea to do soil tests. But what a lot of people are doing now is testing tissues, so actual plant tissue, and the tissue that they test is the petioles. Okay, so leaf petioles. Do you guys remember what a petiole is?
The little bit that holds on to the leaf.
Yeah, exactly. So those little bits. Okay, those you send away to a lab and they test those for nutrient status. Okay. That's supposed to say plant, not plan. Okay, that I can understand is confusing. They provide information about what is in the soil, but not what is in the plant, not the plan. Alright, so petiole tests, this gives you a relationship between soil and plant nutrients, or the